Okay, today we are going to talk about dividing radicals. So just like when we're doing multiplication and we multiply coefficients by coefficients and radicals by radicals, same thing happens with division. So we're going to divide coefficients by coefficients. So a divided by 2 is 4. And we're going to divide radicals divided by radicals. So radical 12 divided by radical 6 is radical 2. And that's it. Okay? Now when we look at something like this, we want to divide 5 divided by 2 does not go evenly, and root 2 divided by 3 doesn't go evenly. The deal with radicals is it is the expectations that we do not have radicals in the denominator. So we need to get rid of that radical 3. How we get rid of radical 3 is we multiply it by itself. And the reason for that is that radical 3 times radical 3 is the same thing as radical 3 squared, and the square and the square root cancel and just give me 3. And that will work with any radical function. So any radical function, so root x times root x is always x. So if we want to get rid of a radical function, that's how we can do it, okay? So we're going to multiply this bottom by radical 3. Now we can't just randomly multiply the bottom of an expression by something, so to make it equivalent, we multiply the top by root 3. Okay, so then we go ahead and just do the multiplication. So this is like a coefficient of 1, so 5 times 1 is 5, root 2 times root 3 is root 6, 2 times 1 is just 2, root 3 times root 3 is 3. We go ahead and simplify, so 5 root 6 over 6. Okay, and these cannot be divided. You cannot divide a radical function, a radical number, by a real number. Doesn't work, not the way the world works, okay? So you can only divide radicals by radicals. Okay, so now we're gonna look at something a little bit more complicated. So we need to get rid of the radical in the denominator here. And we have something, the denominator has two terms, root 2 plus root 3. So we're gonna use what we know about conjugates. So conjugate is like a powerful little math tool that's going to help us. So first of all, what is the conjugate? So the conjugate of x plus 3 is x minus 3. The conjugate of x minus 2 is x plus 2. The conjugate of 5x plus 1 is 5x minus 1. So hopefully you're figuring out what conjugates are. Now, the cool part about conjugates, well, right when you're looking at this, hopefully you're like, oh, it looks like a difference of squares factored. Well, it is. It's the opposite of that. So basically, if I was to multiply this out, I would end up with plus 3x minus 3x. So like the middle terms cancel. So when I multiply conjugates, the only thing I'm left with is the first term squared minus the second term squared. So it's like these two terms multiplied together and these two terms multiplied together. And the same thing here. So this multiplied together is going to be these two multiplied together and these two multiplied together, because those middle terms are always going to cancel. Same thing here. So these two multiplied together, these two multiplied together. Okay? So we're going to use the fact about conjugates to help us get rid of a radical. So I'll show you how this happens. So whenever you have a radical with two terms in the denominator, you need to multiply by the conjugate. So the conjugate of root 2 plus 3 is root 2 minus root 3. Okay? And we can't just multiply the bottom by that, we need to also multiply the top by that. So if you remember from my multiplication video, when I'm doing something like this, I need to make sure I distribute. So let's go ahead and do that. So I have 4 root 12 minus 4 root 18 in the numerator. And then the denominator are conjugates. How conjugates multiply is I do the first two terms together. So root 2 times root 2 is 2. And the last two terms multiply together. So root 3 times minus root 3 is minus 3. Then I can go ahead and simplify the numerator. So 12 can be written like 4 times 3. Take the 4 out. So it's going to be 8 root 3. This can be written as 9 times 2. Take the 9 out. It's going to be a 3. So 12 root 2 all over. 2 minus 3 is negative 1. And I could also write this like minus 8 root 3 plus 12 root 2. So there you go. That's how you multiply the conjugate in the bottom. Now things are going to get even more complicated. So look at this next one. So I'm asking you to divide. If I have two terms in the denominator, I need to do the conjugate. So what is the conjugate of 4 root 3 plus root 3 root 2? Well, it's 4 root 3 minus 3 root 2. And what I multiply to the bottom, I need to multiply by the top. Okay? Now, the top is more complicated than this. I'm going to use the box method to do the top. So right now I'm just going to kind of take a little break from the whole entire thing, and I'm just going to figure out what's going to happen when I multiply the top. So I'm going to use the box. So 2 root 6 minus 5 root 7, 4 root 3 minus 3 root 2. So 8 root 18 minus 6 root 12 minus 20 root 21, 15 root 14. I'm going to go ahead and just write it all out, and then I'm going to simplify it before I do anything else. And I didn't make any mistakes. Okay, so this can be written like 9 times 2, so I'm going to bring the 9 out, it's going to be a 3, so 24 root 3. This can be written as 4 times 3, so I'm going to take the 4 out as, so 12 root 3. That doesn't simplify, and that does not simplify either. Okay, now let's deal with the denominator. So remember that I'm multiplying conjugates. How conjugates multiply is it's the first term, I had a moment I thought it wasn't taping. It's the first term multiplied by the first term. So 4 root 3 times 4 root 3 is 16 times 3. Okay, and then I multiply this term by this term. So 3 root 2 times 3 root 2 is 9 times 2. And then I'm going to go ahead and simplify the denominator there. I'm just rewriting the numerator. Okay, so 16 times 3 minus 9 times 2 is going to work out to be 30. So there you go. Division of radical functions.